Hello and welcome to this podcast for Electropages. I'm your host, Robin Mitchell. Today we're joined by Everspin to talk about critical system reliability. So just before we jump into this topic, could you do me a favor and tell the whole audience who you are, what you do, and what you like to do in your spare time?
Yes, Robin, thank you. This is Joe O'Hare, and I'm the Senior Director of Marketing for Everspin Technologies, a company based in Chandler, Arizona. And we're actually a semiconductor chip company that produces a unique type of memory product used in several critical applications. And to your point on the intro, one of the key features that our customers really like about our product and technology is the added system reliability that it brings into their critical applications.
So before we jump into the technology itself, could you just sort of describe the problem that engineers tend to face when selecting memory solutions for these types of applications?
Sure. Maybe I could just mention a couple of these applications as well to kind of frame it up. But historically, we've had a product that goes into industrial, aerospace, and avionics, aircraft, as well as some military applications. We also participate in a large number of broad applications of medical devices and data storage and enterprise storage type products as well. But we do often refer to the preference of using our product, which is a MRAM type of memory, because of the fact that it brings the ability to continually write to the product without worrying about wearing it out. And that's something that is unique to the type of memory that we have because it also stores the data when the power is lost. And there's no worry about loss of data during critical operations if there's a power interruption. And the combination of those things, the protection of data if power is lost, and the fact that it's kind of worry-free from a device wear-out perspective, gives designers really a lot of confidence in using the product in critical applications of recording data that is happening within a system, a real-time system, or perhaps storing configuration data for how that system is going to operate. And so that's really the nature of what we do and where MRAM plays a role.
So my knowledge of sort of non-volatile memories, things like flash, NAND and NOR,
Yes.
is that they tend to wear down over time due to the way that they're written to with high voltages, barriers breaking down and all that kind of jazz. So what is it about MRAM, about the technology itself, that actually makes it able to have all these writes without wearing down?
Yeah, exactly. So you mentioned it, some of the non-volatile memories that are out there that are in very widespread use, in fact, such as flash memory. So flash also is persistent. The data is there if you lose power and you come back and the data is stored there on a non-volatile basis. And that's what MRAM does as well. The difference being that MRAM, being a magnetic device, in fact, specifically it's magnetoresistive, the data is stored in a magnetic state between ferroelectric materials. And these materials then don't have the same susceptibility of losing that data as charged-based devices, electrical charge, such as flash. And with that, then you have a tolerance to a lot of different things that could happen in a system. With regards to the endurance and the ability to write so many times to it, again, a charged-based device is typically writing through a very thin oxide of some type, at least a very thin dielectric of some type, which over time breaks down. And because they need a substantial amount of current to do that writing and programming. Whereas MRAM requires actually very little current per bit and uses this resistive property more so than separating charge in a dielectric. So with that, we can offer the ability to write many, many times before you start wearing the device out. And just in terms of kind of big numbers. When you talk about number of write cycles with a flash device, normally you'll get somewhere in the range of 10,000 to 100,000 times that you can write to the device. That's not really very many if you think about doing data recording over 10 years or 20 years on a mission. Perhaps like a satellite or deep space mission or something of that nature. So with us, with MRAM, you're able to write basically trillions of times. And the number of write cycles that we afford our customers is somewhere in the range of like 1e to the 15, 10 to the 15 writes versus 10 to the 3 or 10 to the 5. And there you just basically eliminate the need to have over provisioning where customers may, if are concerned about write endurance, they may have extra memory. So if they wear out a block, they can use another block. In this case, they don't have to, or just manage writing cycles over the life of the product. It's not necessary. So that's where I mentioned, kind of the worry-free aspect of it in terms of not being concerned about wearing it out. And we can then act like other types of memories, not just like flash, but also more like a RAM, where you're continuously writing and reading.
So MRAM is something I've sort of watched it in the background in science journals as it's been developed over the sort of past 10 years. How new is this technology as a commercial product?
Yeah, it's a great question because we often talk about emerging memories and emerging technologies. Well, we've actually been shipping this product for more than 10 years. In fact, I think it was 2006 or so when we did our first commercial shipments. And
it's been around since 2006.
Yes, absolutely.
Hang on. So when I see all these papers being published about magnetoresistive memory, because I've seen a lot of these, and they talk about writing current in certain directions, flipping the magnetic field, and it all makes sense, and it all looks great.
Yeah.
Why is it seems to me that it sounds like it sounds like Everspin's been left behind or forgotten in the sense that like no one seems to be talking about a company who's already been doing this and made it commercial.
Yeah. So there's been evolution of the technology over time. And so our first generation of products that we started actually came out of a research effort within Motorola Laboratories back in the day. And it was actually funded by a DARPA research grant from the US government because they did see some of these attributes that we've talked about as having value. And yes, we were able to commercialize it and turn it into an actual memory product. And then the company spun us out over time, and eventually, after being a capital venture-backed private company, we became a public company. So, yeah, we've been doing this a long time. And to your point about, why don't people know about it, or why isn't maybe Everspin recognized so much as some of the bigger memory players that are doing research of today? We actually, from a memory technology perspective, are still a pretty small number in terms of the total size of the market. DRAM and NAND markets are just so big in terms of over hundreds of billions. And we're not. We're a company that is in the $60 million of annual revenue range. So that gets back to where we're being used in these very critical applications, and not necessarily as commodity memory replacement. That day may come, and we do see some intersections of things happening. And to the point about
because one area I see that could be quite useful for things like non-volatile, but it can be read and written like RAM, would be things like unified memory. So you have a microcomputing system where everything is on one chip, including your file storage, your RAM, and program memory.
Exactly. Yeah. And that's what really has the interest of some of the bigger players doing research today. In fact, we have partnered with Global Foundries and are producing our technology today on 28 nanometer based CMOS with MRAM layering on top of that in 300 millimeter wafers. So, we've come a long way with regards to moving the technology down the technology nodes and scaling it. I guess to kind of frame it up then is that we commercialized the technology using our first generation, and we still produce that today our customers really value the long life of the product that we've been shipping, for more than 10 years, and will continue to do so. But the newer investments around 300 millimeter and more advanced nodes have been around spin transfer torque MRAM technology, which is the current generation of product that we're shipping in the higher end. So in that technology, we have achieved densities, chip capacity of 1 gigabit, and very high data rates, very high endurance. And one example of where that's being used is in IBM's all flash arrays for storage requirements. Inside those is typically SSDs. They actually use a different name called flash core module inside those. And they use our product in each of them for a buffer memory for their very high speed writing and data capture and making sure they never lose any of the user data. So that's one example on the more critical side, where they use an MRAM. And on top of that, if you just take a look at what's happened with aircraft, commercial aircraft, I could say pretty safely that MRAM is used in just about most of the commercial aircraft that are flying today. And it's used for things like flight control computers. Sometimes it's used in data recording or even black box recording, not necessarily the large data sets, but certain parametric information. And it's even used in braking systems and cabin lighting and infotainment systems all throughout the aircraft. So we've had very good success there with the largest of the aircraft manufacturers. And what has really happened more recently is it's gotten the attention of the aerospace industry as well, as satellites in particular move into a more commercial realm outside of the military. There's been a much wider adoption and more rapid adoption of technology, just because of what commercial drives. And with that, MRAM is also getting a lot of uptake in the new designs for LEO satellites and for launch vehicles and lunar landers and things of that nature. We tagged on to the Blue Origin launch yesterday of their first all-female crew by stating in a post that we are partnering with Blue Origin on their lunar lander as well. So that was one example of some of the more commercial aspects of what's happening out there that we're participating in.
And when you compare MRAM to flash memories, where you've got charges being trapped in floating gates, does that make MRAM more resistant to things like radiation than traditional flash memories?
Yeah. That's actually the perfect question, because both of those examples of aircraft as well as now aerospace and satellites really value that, and much more so in satellites, as you can imagine. So the charge that is stored in a magnetic state is not necessarily susceptible to disruption by the energy from radioactive particles. So there's a lot of value in MRAM in these applications. So there's a range of different radiation tolerances that are acceptable, for different missions. Generally for like constellation satellites for communication, or all of the things that are happening in the LEO range, can use MRAM as is, because we offer radiation tolerance. We don't actually measure or specify how much radiation tolerance. We leave it to the government laboratories, that do, or national laboratories that do that type of work.
And I guess in an application like that, it's hard to give a guarantee. You need to say, you build it, you have to test it and see if it works, because in a critical application like that, it's probably quite hard to test the MRAM in the first place against radiation dosage and to figure out if it works.
Well, but there are ways to do it, because that's where the laboratories come in, right? So they basically
that's like the intense levels of radiation.
Yeah, that's right. Yeah, they can do that, and it's a very controlled situation. But from that data, they can then assess, what your tolerance is to different levels, and so that gets done on our product by others. And as a result of that, the space exploration companies have really made MRAM a preferred memory for storing code, for updating software and systems and storing it there locally. Uh, because in addition to the radiation tolerance, with the write endurance that we have, you can write more often, and you can also write much faster than you can to some of the other types of memories. So therefore, if you think about like doing it over the radio, or in the case of a satellite, maybe definitely some type of radio communication, uh, that amount of time that it takes to update code could be very important. And MRAM, plays a role there as well. So yeah, we've had a good uptake in the aerospace industry. I would just mention also that if customers in the military side are looking for something that is much more radiation hardened, then we also have a way to serve that market, because we license our technology to some of the defense contractors that do that kind of business, such as Honeywell or Front Grade Systems. And they take the technology and do additional design and process work to make it radiation hardened and sell it, at the military level as well. So lots of attributes here in MRAM, and I just wanted to come back to why it doesn't get bigger faster. It will, because as you mentioned, it looks like a very good fit for embedding into a system inside of a chip. So each of the major foundries, TSMC, Global Foundries, Samsung, and a number of others have already offered to their customers MRAM as a non-volatile memory within their SoCs, much like they do with SRAM and other types of memories. So you can get macros now from those guys and integrate it right into your SoC. And I think that's going to be a very good business for them. We're much more focused on the discrete memory side of things. And as we continue to jointly work with them to get to the more advanced nodes, we'll be able to offer 1 gigabit and higher capacities with a continued advantage over something like a NOR flash memory, where more performance is required on the writing side. So I think that's going to actually open up some additional opportunity for us and for the industry as well.
Now, if I understand correctly, you guys have a new announcement in terms of your MRAM being integrated into some FPGA products. Am I right about that?
That's right. Yeah, very good. So, we were at Embedded World. Well, I guess it's already almost a month ago.
It's been about at least a month now.
Yeah. So, but we did have a very good show there, and we talked about a couple of things. One is what you just mentioned, that because our densities are increasing, and we also have the look and feel of a NOR flash from a pinout and command perspective, then we can be viewed as a very high performance configuration memory for FPGA, or a multipurpose memory for an FPGA if that particular design is using memory for more than one purpose, which they do now, because they're basically building small systems into these FPGAs. And Lattice Semiconductor has now announced that within their tool set, their Radiant design tool set, where FPGA designers build up their own systems, they can now select MRAM, in particular our part numbers, for use in those systems, either as configuration memory or for other general purposes over a serial port. And so at this point now, you have a whole new set of system designers that have MRAM at their disposal in their own design environments, which I think is going to really make a difference for us and for Lattice, for the customers that are looking for the added reliability, for the added system performance that they get with using MRAM. And that could be anything all the way from aerospace, again, that we've talked about, or even into things like gaming systems for casinos. That's been an interesting one for us as well, because some of the gaming manufacturers, they basically are building very high performance computer motherboards that have the gaming profiles, they're using MRAM extensively now. And that's been another very good market for us. Again, the things they like are the very high write endurance, the ability to write fast, and the ability to make sure that if they need to capture transaction data or maybe some payout transaction, that this stuff is all regulated and has to be reported at the casino level, then MRAM could play a very significant role in those machines as well.
One area that I personally see that could be quite useful when you mentioned the FPGAs working with the MRAM solution, myself, I would like to see it in a situation where if the FPGA's configuration experiences something like CMOS latch up because of some radiation situation, let's say on a satellite somewhere, you can essentially reboot the FPGA. It will read off from that MRAM and restore itself. But because you've got the MRAM, it's got that resistance built in, so it almost doesn't matter if the FPGA itself has a reduced tolerance in terms against radiation, because you can rely on the MRAM to always reprogram it to get it to a point where it's working.
Yeah. So with regards to that use case in aerospace, using with an FPGA and the radiation tolerance, I really think that's one of the main drivers. I can't speak for Lattice, but I think that's one of the things that really got their interest. And some of their customers were requesting that specifically. So that led to offering this within their tool set. So again, that's absolutely right. Now, with MRAM, not concerned about losing that data or having the data corrupted. In the case of latch up, I do want to caution. Now you're getting into some areas of the CMOS, more so than necessarily the MRAM storage bit. And that's where, as I had mentioned, some of our partners had taken our designs and done some additional design, layout, and process work to make it actually immune to that as well. So again, it really depends on what the radiation requirements are.
And sort of looking towards the future, do you see MRAM becoming directly integrated into the silicon layer of FPGA, so that you could effectively have a device that's inside a radiation housed sort of environment where it's got the configuration on board and it's got the immunity to have essentially an infinite number of writes?
Yeah. So and you have the ability then to boot up very quickly, because you don't have to download again, because it's already stored there in a semi-permanent way, right? So yeah, absolutely. And in fact, you're hitting on another area of development within Everspin right now that we have announced, which is that we're using the MRAM technology in a non-traditional way to create very small registers or clusters of memory that can be used within an FPGA fabric. And so, we've tuned the attributes of that technology to be most useful for use within an FPGA. And together
and to add on to that, one thing I can see being quite useful is if you're building your FPGA design, let's say you're using a schematic layout and you want to put down a register, you could choose between a CMOS register, which is your standard one, and if there's a part of your circuit that needs to be absolutely reliable, you put down the MRAM register.
Exactly right. You could very well do that. Absolutely. And because of the fact that MRAM processing has been made compatible with all of the CMOS, the registers are typically built out of some type of SRAM type of architecture. So you could do that easily. And so we actually are working together with QuickLogic. QuickLogic has been an FPGA provider for some time now, and they're actually building a chip, an FPGA, with MRAM as part of the programming fabric within it.
So just before we wrap up this podcast, I've got one more question for you. For the audience who are watching this video, if they want to get involved with Everspin's MRAM solutions, what would you recommend that they do?
Call us. Yeah. So because we've been in the business for as long as we have, we do have a direct sales force. We have a sales distribution channel using major distributors around the world. and very easy to get a hold of by just looking at everspin.com, and you'll quickly find a way to reach us. Or even if you're ahead of the game, just go directly request some samples and get on board with some of the application support that we have online. So that would be the way I'd recommend anybody who wants to get into this. Certainly now, they've got me out there talking about it. So if anybody wants to contact me directly as a follow-up or has questions about it, I'm available as well.
Fantastic. Thank you ever so much for taking the time to see us today.